Hi, my name is Dave Pasquale. I'm the owner of Pasquale Aviation, and today we're going to talk about landing gear down springs, also known as a kick down spring. This one here is a main gear down spring, and I have also a nose gear down spring. Both of these are out of the same airplane and the other main gear, which is this one here. Uh, I've started testing these at every annual inspection. The reason I did that is because I had an airplane where I was taking it out of the hangar here, and when it went off the little lip of the lip that is between the concrete floor of the hangar and the ramp outside, the left main gear collapsed and the airplane fell down onto the wing. There is a danger of that happening if you're pushing the airplane around, or if you have a landing gear failure, a landing gear motor failure, if the motor fails for some reason, or you have an electrical system failure, those kind of things. The only thing that's holding the gear over center at that point is the downspring. If the power is on and the landing gear is functioning correctly, and you have an electric hydraulic landing gear system, if for some reason the strut starts to go, straighten out and go under center, and everything's rigged correctly, the down limit switch will turn the landing gear motor on and push the gear back out. Sometimes I see this when I'm doing run-ups prior to a annual inspection. If you go to full power, you'll get a light will come on, or one of the green lights will go out and the red light will come on. You'll see it briefly. That's usually an indication that the rigging may be a little off, or it could be that this downspring's a little weak. These also affect when you do an emergency extension. In the shop here on jacks, we test that at every annual. Sometimes we've had them where weak springs will cause the gear to not fully come out, which obviously isn't great, but isn't necessarily an indication of how it would work in flight. The main gear on these airplanes open toward the aft of the airplane, so the air tends to push them out. The nose gear, on the other hand, is opening into the airstream, so that one's a little harder, especially if you have an airplane that is 76 or later and has that flat door in the front that acts kind of like an air brake. On those airplanes, it is absolutely critical to get the airspeed down low. Basically it's stalling airspeed when you do the landing gear extension. If you don't do that, the nose gear will come down, but it won't lock, and it'll fold up when it touches the ground. But at any rate, I wanted to talk about testing these. So the way I test these is I take and mark 1 inch on the shaft. So the inner shaft is the piece to the right, and then I have my ruler here butted up against the upper housing, and then I measure 1 inch out and take a Sharpie and draw a line on it there. That is how far we're going to compress this. And so if I take my scale here, I zero the scale with the downspring on it, because you don't want to have the weight of the downspring factored into this. We want to measure the spring tension. Then once it's zeroed, you take the scale and you basically push the downspring into the middle of the scale. So I'll push it down until I get to my mark, and that's right there. This one here, you can't see it on the scale, is reading right there. It's reading 47 and about 47.5 pounds. When they're new, they read about 53 pounds, give or take a little bit. I've had some that were like 52, and some that might have been 54 pounds. I had one that was like 48, and that one there I sent back to the factory for a replacement. To take these apart, I'll go over that next. And before I go over that, with the one that the gear collapsed on, the tension on that was like 38 pounds. You know, doing this test, 38 pounds to collapse at 1 inch. So anyhow, I'll talk about how to change it. I have two tools here that I made. This one here is made out of Delrin, and it's basically just a fork. I have another one here made out of a broom handle, which is just as easy. Either option. What you do to take these apart is you take the fork and you push it down in the end of the housing, and that's going to push on the spring that's inside this thing. And then this tube, you're going to want to take the tube out. So you push down on it till it takes the pressure off the tube, and then you pull the tube out of it, and then slowly and carefully release the spring. If you're not careful, it'll fly up and hit you in the face. And there's the spring. And you can take the housing apart, but here, I'll pull that apart. There you go. You take the housing apart by pushing the bottom up through. You can see here it's got a larger ring on the end. That actually keeps it from extending all the way out. If you have an earlier airplane that doesn't have this rod end on it, some of the earlier ones had just a solid tube running to the end with a bolt going through it. On those there, this collar up here on this end is a little wider, and so to make your over center adjustment, you have to machine this collar down in order to get the right adjustment. Also on those, I believe most of those, if they're like the engine-driven hydraulic pump system, those airplanes there have a different over center adjustment than the later ones with the electric hydraulic system. Both of those systems are a little different too, in that the older system with the 3 levers that are under the seat there, when the handle snaps back to the neutral position, it does trap fluid in the actuator. That sort of works like a down lock. That'll help you when you're taxiing and things like that. That's basically all that you have holding the gear down between the over center spring and the fluid that's trapped in it. If if for some reason that fluid leaks out of there and the gear comes up a little bit, there's nothing really to keep it from collapsing. So that's a difference between the electric hydraulic and the engine-driven hydraulic. Also, I believe the oil dine system, the late model electric hydraulic, may also trap some fluid in it. So here, I'm going to put this one back together. So to put it back together, you do the reverse of what you did to take it apart. You push it down on the table and bring the spring in. Line the fork up with the hole. And then put the tube back in. If I can get it all the way through. There, I got it all the way through, and there we are back together again. Now these things here too, I know Mike said in his post, or in the factory's post, not to lubricate these. I've worked at Whitmer's for 18 years, and I've been on my own since 2017. Been working on Bellancas for 25 years. We've always lubricated these. Basically, we're taking these apart every year and cleaning them and testing them and all that stuff. We always clean the housing. When I put new springs in, I coat the springs with Lubriplate. I coat the housing out here with Lubriplate as well. There is a chance that adding grease to something like this collects dirt, and it can. My experience has been that it has not caused wear. I've not really seen wear in the housings, but what I do see is like what this one has here, which is rust. Having a coat of grease on there will help control the rust. I also see sometimes, and you'll hear it sometimes, as the gear is moving, you can hear the spring clicking past the end of the inner housing. I don't think this one will do it. You can hear it a little bit. Put this on here. I don't know if you can hear that when it gets farther in, right in there. you might hear that a little bit. Whoops. You might hear that a little bit. That's the spring coils going past the end of the housing, and in my mind that ought to have some lubrication in it to help it slide past. I've had a few on occasion where the inner housing was too small or the spring was too big and they wouldn't compress properly. Not really sure why that was the case on those, but again, any lubrication can only help that. So the other one here, I'll do the nose gear too. I'll test the nose gear one. Even though the nose gear is shorter, they generally come up about the same when they're new. Nose gears tend to get compressed more during retraction. If you watch these during retraction, this end here is all the way up inside the housing. That's why it's super important to get the proper spring in this. If you have a spring that's too long, it will bend this rod end. Also, if you have the over center adjustment set too far over center, it causes the springs to all bind together and it'll bend this rod end. And I've seen at least one airplane where this rod end broke off and the nose gear went way over center and then wedged, or no, it did go this way. It went up and it wedged, like this is the nose gear. The center drag strut went in and braced against the nose gear, and the nose gear was back like this, and at that point the pilot had no directional control on the airplane and ran off the runway and had a prop strike and all that kind of stuff. So it's super important to have these adjustments correct and to have this stuff properly maintained. So I'm going to try checking the tension on this spring just to see what it is. I have the scale zeroed, and then let me push this into it here. There's 1 inch and it's at 35.5 pounds. So this one here probably ought to be changed out. Again, there's no, I don't know that I mentioned it earlier, but there's no published limit for the for these for these springs. The factory, from what I understand, was using a fixture that they hooked a torque wrench onto, and it was torquing just against the bare spring. So it's a different measuring system and one that's not repeatable in the field. So their minimum measurement might have been 12 foot-pounds or something like that. It doesn't mean anything to what we're trying to do out here in the field because we don't have the fixture. You may notice on the bench here I have a bunch of down springs. These are all old ones. You can see that the length is varied among almost all of them, and that's from them being in service. A couple of these down springs, like this one here, look like it's been modified from its original configuration. The end of the spring, instead of being like this where it's machine, where it's closed in on itself, this end here is just cut off and sticking up. I don't know why that's the case. 3 of the springs here are like that. Here's another one that's like that, and then here's another one that's like that. You can see from these springs that this is probably a nose gear spring and that's probably a main gear spring. That's about the difference, but even among them, there's some differences there. I'm going to stop the video here and go see if I have a new spring to compare with these old springs to show you that difference. So I'm back here with some new springs. I have several varieties. I have here, these are all 3 new main gear springs, and then I have what I believe are 2 different nose gear springs. You can see the difference in length there, and here's the difference in the main gear to that nose gear. I think this one here is a 79 and newer nose spring, and this one might be a nose gear spring for what is going to be the adjustable downspring assembly that's prior to 79. This one here I have listed. This was one that didn't test right. I think that was the one I said that I sent back earlier. I didn't send it back, but I got a replacement for. It just didn't come up correctly on my test, and it's slightly shorter than a new mainspring. The one thing to be careful with these, and maybe I can convince Mike at the factory to change the way they label things, is you'll notice this one doesn't have a label, this one doesn't have a label, but these two do. And what Craig was doing at the factory was he was writing the tag for the downsprings and putting them inside the spring like that. We had an incident where one of our guys put a main gear downspring in a nose gear spring, and it ended up damaging the rod end. And basically what my investigation turned up was that we had ordered a nose downspring, but we were given a main downspring, and it came out of the box and was put on the airplane. I don't know that it had a tag on it, or if it had a tag with it in the box. The other issue with these tags is they don't say the application on them. Let me see if I can get this one out. This one here says, it says part number 19465-5. The description is a spring, and it has the type certificate, the A18 Charlie Echo, and the model 1730A, and that's it. It doesn't say what position it goes or what serial number it's effective on. That may be something that if Mike is able to do it, that would be a good thing to do, would be to give us another check on these other than the part number, because as you can see, the spring coil diameter is the same, the wire thickness is the same, and the turns per inch are the same. The only difference is the length. So as of now, you guys have to be really careful in selecting which one goes in the airplane. Mike can help you with that as far as serial number effectivity. He has all that data from the factory, so you can figure that out. The other way you can check these is by counting the number of turns over the course of the whole spring. That can help with that too. So that's what I have to say about downsprings at the moment. If any of you have any questions or anything, hit me up with an email or a comment on the video. And thank you for watching. Talk to you later.